it down using a smaller scale factor, basically. All right, so our objective is to find and use equivalent ratios using a table, model, or double number line to solve real-world problems. So our first problem is about lemons, and it says that lemons are sold in bags of 6, and that one bag cost $4. So if we wanted 24 lemons, not 24 bags, but 24 lemons, how much would you spend? So the first one says we're going to write a ratio of lemons to dollars. So 6 lemons versus the amount of dollars. So remember I said a ratio tells you how they want you to write it. So how would my ratio be written?
6 over 4.
Yep, 6 over $4. Okay? So what are we trying to find? What is the unknown?
How much money would it cost if you bought 24 lemons?
Yep, cost of 24 lemons. Absolutely. All right, and so the example says one way to find the unknown number is to use a table. So that's what we are going to look at today, is the table. So we have one bag, 6 lemons, $4. So we know that. 2 bags, 12 lemons. What's it going to cost me? $8. Yep. So 3 bags. How many lemons?
18.
Yep. And that's going to cost $12. I'm assuming this is 4, right? Because 6 times 4 is 24.
Right.
And then what would my cost be?
16.
Yep, $16. All right. So look at the results in the table. What do you notice about the number of bags of lemons, the number of lemons, and the cost? So what is my pattern? What do we know?
It keeps adding itself to the value.
Yep.
For all of them.
Yep. So what happens is, as we, I can't even spell we, as we add a bag of lemons, we are adding 6, right? And the cost is adding $4. So as we add a bag, we're adding 6 lemons and adding $4 to my cost. Okay? So that's how you would use a table, which I know we've looked at those. And I know that on your test you're going to have several tables where you'll have to fill in the values. Okay? You'll have to scale things up or scale them down. All right. Let me pause there for just a second and give you guys some time to write it and to fill out that table. All right, are we good?
Yes.
Okay, awesome. All right. So another way to find an unknown number is to find a factor that generates the equivalent ratio. When both quantities are multiplied by the same number, the result is equivalent ratio. Find the unknown number using this method. So usually you will see it called a scale factor. So scale factor means what number do I use to multiply the numerator and the denominator to get my answer. So since we're looking for the cost of 24 lemons, our scale factor is going to be 4. Remember, scale factor means you multiply the numerator and the denominator by that same number. Okay? And so using our table, how many lemons, 24 lemons cost how much money?
$16.
Yep. So $16 is what we'll put there. So then the turn and talk says, how could you use the relationship between 6 lemons and $4 to find the relationship between 24 lemons and the cost for 24 lemons? Well, what did we use?
We multiplied by 4, sorry.
Yep, so that we used the scale factor of 4 to multiply the numerator times the denominator. And y'all cannot see that, so let me move that. Are you ready? Everybody's got it?
I have it.
Okay, awesome. All right, so number 2 says we are going to try to make some slime. So it says the diagram shows a ratio of hot water to make slime and cold water. He wants to use 18 parts of water in total. How many parts of cold water does he need to make slime? All right, so they're going to walk us step by step. So look at the tape diagram. What is the total parts of water shown? So this is 6, right? This is, so what's my total? Yep.
9.
Okay, so 9 parts. So now the ratio, so this is how we're going to set it up. Total parts to cold water. So total parts was what?
9.
Yeah.
9.
Cold water is?
3.
So 9 to 3. So what is the relationship between the quantities in the ratio of part B? So what is my relationship? Total to cold.
If you multiply 3 by 3, it'd make 9.
Yep. So the total is triple, right? The cold water. Because just like Clementine said, if I multiply 3 times 3, I get 9. So it's triple the amount. All right, D says, how could you use the relationship between the quantities in part B to find the parts of cold water needed for 18 parts of water? Okay, so what would my scale factor be to get from 9 to 18?
2.
Yep, so this would be 2 and this would be 2. So how much cold water do I get?
6.
Yep. Okay? So then E says, how many parts of cold water will Jariah need if he has a total of 18 parts of water? Well, we already said that. 6 parts of cold water. All right, so now we're going to look at F, and we're going to look at 36 parts. So if she wants 36 total parts, how much cold water will we need? So what is my scale factor?
Times 4.
Yep. So times 4 times 4. So my cold water needed is what?
12.
Yep. All right, so now let's switch to hot water. So how many parts of hot water will Jahara need if he uses a total of 18 parts? So we've got to go back and recreate my original scale factor, right? So 9 total, but how much hot water do I have?
6.
Yep. So that ratio would be 9 to 6. We're still moving to 18, so what's my scale factor?
2.
Yep.
6 times 2 is 12.
Yep. So 18 total and 12 hot. All right, so what about 36? How much hot water? So 9 to 6 equals 36. What's the scale factor?
4.
Yep. So 6 times 4?
24.
Yep. So 36 total to 24 hot. Absolutely. All right, so the turn and talk says, how can you use the tape diagram to check your answers? So what could we do? So if I know it's double, right? And you're probably not going to be able to see this, but if I know it's double, I could split this in half, right? If I needed to. So now that would be 12 hot water. And I could do the same thing if it was double cold, right? If it was tripled, I could split them into 3s. If it was quadrupled, I could split each one into 4s, right? 4 equal parts. So that's how you could use that tape diagram, is to divide them into sections. Okay, so we're going to go and write divide to sections. Are we good?
Yes.
Peyton, are you good?
I'm good.
All right. So let's look at number 3. This is our double number line. So it says a race car driver completes 5 laps of a race in 3 minutes and 30 seconds. Then the driver continues driving at his rate. How many laps will the driver complete in 17.5 minutes? So what is the ratio of laps to minutes?
5/3.
Okay, I agree with the 5, but it's 3 what?
Oh, 3 minutes and 30 seconds.
Right, so we're going to do 5 laps, and I'm going to convert that 30 seconds to 5/10, right? So 3.5 minutes. So 5 laps per 3.5 minutes. All right, so we're going to complete that double number line. So we know the first box, 5 and 3.5. So what is my second box? Yep. How do we know that?
Because if you look down, 3.5 times 2 is 7. So
Yep.
then you'd have to do 5 times 2 to get 10.
Absolutely. Good. All right. So what is the next one?
15.
Yep. And so my pattern continues, right? So 5, 10, 15, 20.
25.
Yep. 30.
5.
35. All right. What about my bottom? What does that pattern continue?
So after 3.5 is 14.
Yep. Because if I do 3.5 times 4, right, it gives me 14. All right. What's the next one?
17.5.
Yep. And then what's the last one?
28.
Yep. 28. So it says, explain how you found the missing numbers of laps and minutes. So we could do it one of two ways, right? We could multiply 5 and 3.5 by the scale factors, right? Or we could add 5 and 3.5 each time. So we can either multiply by that scale factor or add. That's a good thing about a pattern. When it's constant, if you can't figure out your multiplication tables, you can just continue to add them together. All right, so it says another way to find the unknown quantity is the scale factor. So what number did we multiply by 3.5 to get 17.5? So 1,
5.
2, 3, 4, 5. Yep. So my scale factor is 5. And so we already know that it's
25.
Yep, 25 laps. Yep. So then the last part says, how many laps will the race car driver complete in 17.5 minutes? They will complete 25 laps. Okay? All right, so we are to that check understanding. Okay? I do want to mention number 2 real quick before I release you and we come back and check it. So if you notice, the Eiffel Tower says it's 2 centimeters for 6 meters. So how many centimeters will go into 6 meters?
3.
Yeah. So that means I got 3 meters that will go into 324 meters.
Wait, I'm confused on what just happened.
How many meters, how many centimeters can I get into 6 meters?
3.
Yeah, 6 divided by 2 is 3. The reason why I had to convert this to meters is because I have meters here. So now I can do 324 meters divided by 3 meters.
Okay.
Okay? All right, so go ahead and work on those. I'll give you probably about, about 8 minutes, and then we'll come back and check them. Remember, if you're waiting on me to check, move on to the on your own. I do not expect you to finish all of the on your own today. All right, we will have some time on Monday. We'll have all day on Monday to work on it. All right. I know it's 3 pages. Just work on as much as you can work on today. And then on Monday, I will take some of the problems off. Okay? All right. So, 8 minutes.
Did I already do this on N2 Math?
The check understanding, or you mean the on your own?
I mean, I'm asking if I did the check understanding thing.
Well,
Because
if
I
you,
know I did, like, the on your own.
yeah, if you did the check understanding, though, it doesn't tell me if you did the check understanding because I don't assign it. The only thing I assign for you guys is the on your own. So I can look to see if you've done the on your own. I don't even know if I assigned it already, but we'll see. Hold on.
I've done, like, up to 5.5. I just finished the 5.5 today.
Okay, give me a second. 5.5. Yes, it says one person has finished, and that is you. So, yes. So you have already done it. So if you want to log out, you are good to go.
Okay, thank you.
All right, have a good weekend.
You too. Bye. Does the designer spend on plants? So the ratio is 2/7.
Mm-hmm.
And I put the 22 on top, and 2 divided by 22 is 11, and 7 times 11 is 77.
Yep.
So I got 22/77.
Absolutely. That works for me. I know, Aiden, you did it a different way. You did 7 times 22, isn't that what you said? And then divided it by 2? I think that's what you said. Or you
I
took
said
half.
I did 22 divided by 2 and then
Yes.
divided by 7.
Yeah, same thing. Same.
So I just had the actual like money.
Yeah.
$7.
Same idea. Same idea. All right, you wanted to do 3 there, right, Aiden?
Right.
Okay, so who wants to do number 2? Anybody? All you have to do is divide.
I mean, I'll do number 2.
Okay.
Also,
What'd you get?
108.
Okay. Yep, because 3 goes into 3, 1. 3 doesn't go into 2, so that's the 0. And then 3 goes into 24 8 times. Yep. All right, go ahead, Aiden, on number 3.
Alright, so 371 divided by 53 equals 7. And then 7 times 1 is 7, so it'd be 7 gallons.
Yep. Okay, you got it. All right, so you guys still have about 12 minutes. So you should be able to work a little bit on your own. Of course, I will still be here if you need me. And then you will have Monday to work on it as well. Okay? All right, so go ahead and start working, and I will be here.
So are we doing all the questions?
So I said, go ahead and just start working on like 4, 5, 6, and 7, and then I'll take some of them off on Monday.
Alright.
did y'all go? Oh, there you go. Okay, somebody sent me something in the chat. Let me see if I can get over there. For number 4, can you tell me how ratios are equivalent? So you usually use the scale factor. So like in this one, if the ratio is 24 to 54, right? I would need to multiply each one of them by the same number. So this would give me 48 and this would give me 108. So you can see that they were not multiplied by the same scale factor.